In this video, we want to integrate sine of x over cosine of x minus sine squared of x. First of all, we want to get rid of the minus sine squared of x in the denominator. So let's recall that cosine squared of x plus sine squared of x always equals 1. So minus sine squared of x is then nothing but cosine squared of x minus 1. So we can rewrite our integral as sine of x all over cosine of x plus cosine squared of x minus 1 dx. Now a nice substitution would be u is equal to cosine of x, because then we get du is the same as minus sine of x dx, and dx is then nothing but du over minus sine of x. And if we plug that back into our integral, we'll see that the two signs cancel out. So we get sine of x over minus sine of x times 1 over u squared plus u minus 1 du. Now this is of course then the same as just minus 1 over u squared plus u minus 1 du. Whenever you have a polynomial of second degree in the denominator, what you want to do is partial fraction decomposition. In order to do this, we need to find the roots of u squared plus u minus 1. So let's set that equal to 0. And applying the quadratic formula, we get that one solution is minus 1 minus the square root of 5 all over 2, which we can rewrite as minus 1 plus the square root of 5 over 2. And another solution is minus 1 plus the square root of 5 over 2. And now we can factor our integral nicely, giving us minus the integral of 1 over u plus 1 plus the square root of 5 over 2 times u minus 1 plus the square root of 5 over 2 and times du. Now let's erase this and start doing the partial fraction decomposition. So in general, this will be equal to a over u plus 1 plus the square root of 5 over 2 plus b over u minus 1 plus the square root of 5 over 2 du. And now we need to find out what a and b are. And the way to do this is to just recombine the fractions, giving us minus the integral of au minus a times minus 1 plus the square root of 5 over 2 plus bu plus b times 1 plus the square root of 5 over 2. And all of that over u squared plus u minus 1 times du. Now, if we have a look at our original numerator, we see that all of this here should be equal to just 1. And so we don't want any u's in our new numerator. And that tells us that au plus bu should be equal to 0. But that can only happen if a is equal to minus b. On the other hand, b times 1 plus the square root of 5 over 2 minus a times minus 1 plus the square root of 5 over 2 should be equal to 1. Now, multiplying both sides with 2, we get that b times 1 plus the square root of 5 minus a times minus 1 plus the square root of 5 is equal to 2. But now we can make use of the fact that a is nothing but minus b. And so we can rewrite this as b times 1 plus the square root of 5 plus b times 1 minus 1 plus the square root of 5. And all of that is still equal to 2. But now this simplifies nicely to just 2b times the square root of 5 equals 2. And then of course b is nothing but 1 over the square root of 5. But this tells us that a is the same as minus 1 over the square root of 5. And if we have a look at our integral in this form here, we'll see that we can now write it as minus 1 over the square root of 5 times the integral of minus 1 over u plus 1 plus the square root of 5 over 2 plus 1 over u minus 1 plus the square root of 5 over 2 du. And if we distribute the minus, we get the plus here and a minus there. And now we can easily integrate this, giving us 1 over the square root of 5 times ln of u plus 1 plus the square root of 5 over 2 minus ln of u minus 1 plus the square root of 5 over 2 plus c. But now recall that u is the same as cosine of x. And furthermore, we want to notice that the golden ratio is defined as 1 plus the square root of 5 over 2, and its conjugate is defined as 1 minus the square root of 5 over 2. So we can rewrite this as 1 over the square root of 5 times ln of cosine of x plus the golden ratio minus ln of cosine of x plus the conjugate of the golden ratio plus c. And now, using logarithm rules, we can simplify this to cosine of x plus the golden ratio all over cosine of x plus the conjugate of the golden ratio plus c. And we are done.